Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss different ways to send messages to Kafka Topic. Okay. So already in my previous video, I started discussion on Kafka. I have started discussion from scratch. That is how you can install Kafka in your Windows machine. What is the Kafka architecture? I have discussed in detail how you can integrate Kafka with Python. What are the important producer properties you need to keep in your mind when you are designing the system. All this I have discussed in detail, right? So if you want to know those detailed explanations, you can go through the link given in the description box because those videos will surely help you to understand the new concepts in a much better way. Okay, so without any further delay, let us try to understand different ways to send messages to a Kafka topic, okay, using Python API. And there are majorly three primary methods for sending messages. Number one is fire and forget. Okay, that is, I will send the message and then I will not bother whether it is really reached or not. Then there is synchronous send. That is, in synchronous manner the message will be sent. Once the message is written successfully, we will be getting a response back. Once the confirmation is done, we will send the next message. Obviously kind of bit slow. And then another one very interesting technique is asynchronous send. Okay, what are those? Let me explain in detail. So let's first consider the first technique, which is fire and forget. Okay, so in this technique, we send message to the Kafka server and don't really care if it arrives successfully or not, because most of the time it will arrive successfully because Kafka is such a reliable system and Kafka clusters are generally highly available, and the producer will also retry to send the message automatically if it fails for the first attempt. That much reliable our Kafka is, right? So most of the time we are not bothered about that whether it is really sent successfully or not, because 99.9% time it will be sent successfully, okay, until and unless really something goes wrong, okay. But however, using this technique you can obviously expect that there is a possibility that some message might be lost, because here we are just sending messages. We are not at all getting any acknowledgement that okay, it is written successfully or not, right? And now let me show you with real-time demo. So first what I will do, I will start my zookeeper. Okay, so here I will go to PyCharm, I will go to terminal, and here I'll paste the zookeeper bat file code, and here I will start my zookeeper, which will run in default port 2181, right? So here you can see that zookeeper is running in port 2181 by default. Now what I will do, I will basically start my Kafka server in the port 9092, which is the default port, right, in a new terminal. So here I have started my Kafka server, a fresh cluster I have started. I have deleted all the earlier logs basically, okay, right? And then what I will do here, I am basically creating a topic having the name hello_world1 with partition 1 replication factor 1, because just I am doing POC. In the real world environment we are enabling replication factor so that if one broker goes down, still the messages can be accessible in the cluster, right? And partitioning also I am keeping 1, but in real environment generally we are having more than one partition. That is fine. So just for POC purpose I am doing that, and here you can see that the topic is successfully created, okay, right? Now we can use this particular topic to do all kind of demo. So here first I have written the code. First let me just uncomment this particular code, and here you can see it is a very simple code. First I am importing sleep from time module just to make some interval in between successive messages, okay. And then here we are importing dumps from JSON, because JSON.dumps, JSON.loads often required because we are going to send JSON data in Kafka cluster. And here we are importing KafkaProducer, okay. Then here we are giving the topic name what just now we have created, that is hello_world1. And then here we are creating the KafkaProducer, where we have mentioned the Kafka server which is running in our localhost 9092, and value serializer we are providing here. Basically we are going to send JSON values. So first we are using json.dumps to convert the JSON data to string, and then here I am encoding that in UTF-8 format. Obviously whenever we send messages to Kafka cluster, we need to serialize the message, right? So that's what is done here, okay, right? And then here what we are doing, here we are iterating in a for loop. We are sending 100 messages, we are generating the data, and where we are using producer.send to send the message, okay. You can see here we are not waiting for any return response, that whether it is returned successfully or any error happened or something. Just we are sending, and then here in between each message sent, keeping a sleep time of 0.5 seconds. Okay, as simple as that. And rest of the complete code I have commented because I want to explain different scenarios. So I will come to that. As of now, before starting the producer, let me start the consumer also. Okay, so that I can show you that what problem we might face in this kind of fire and forget method where we are not waiting for any response. Okay, so here you can see we have started our consumer. Okay, right? And then here I will start running my code. Okay, right? So here you can see number 0, number 1, number 2, number 3, the producer is producing the messages, and here our consumer is consuming. Okay, as of now it is perfectly working fine because Kafka, as I have already told you, that it is very reliable system. So without expecting any return also, we can see that the messages are successfully sent. Okay, but suppose something goes wrong, maybe our broker goes down, but still the producer is sending messages and we are not aware of that, right? So let's see what happens there. So in the second terminal here, our Kafka broker is running. I will just stop this particular broker intentionally. Okay, so here I have terminated my broker. Here in the consumer side, you will see here it started throwing error because consumer is not able to connect. If I go to my producer section, you can see here still it is producing the messages. Okay, but actually here in our consumer section, the messages are not even reaching because our cluster itself is down. Okay, but our producer is not even aware of that. It is just sending the message. It is not even bothering that whether the message is sent successfully or not, any error happened or not. Okay, that's the problem of fire and forget method. That's what I have highlighted here, that in this particular technique, some message will get lost. Okay, and you can see here clearly that in this particular case, all this message, whatever we have published after the broker went down, all those are lost. Because if I restart my broker, then also these messages even have not reached to broker, right? It is not even available in cluster. So obviously these are lost messages. Okay, so we have understood what is the disadvantage in fire and forget method. Okay, so now let me comment this particular piece of code so that I can go to the next approach. Okay, so what I will do by the time here, I will just stop my consumer also. Okay, right? And then let's switch to the next technique. The next technique, what I want to discuss, that is synchronous send. What is synchronous process? I hope by this time you are already aware because already several concepts related to synchronous process I have explained in big data domain. That is basically one particular operation will complete and then only the next operation will be starting. It is just like suppose you went to watch a movie and you are in a line to take a ticket, and in front of you there are 3 people. Until and unless they get their ticket, you cannot get your ticket because obviously only one cashier is there. So it will happen serially. First, whoever is there first in the queue, he or she will be getting the ticket, then the next person, then when your turn will come, then only you will able to get the ticket, not before that. Okay, that's the synchronous send. Okay, so in this technique, what we do, we send a message using send method, and that send method basically return as a future object. Okay, and we use get to wait on the future, and we observe whether the send was successful or not. If the send is successful, then we go to next message. If the send is failed, then we capture that particular failure. The client side producer will understand that this particular message our producer was not able to publish. He or she will be completely aware of that. Then it will try for the next message after some time. Okay, like that it will work. So let's see how synchronous method works. So here is the synchronous send code. Let me just uncomment that particular part. It will make much more sense when I will show you the demo. So here you can see the first part is as it is, no change. Only thing change in the for loop. Okay, so here I am generating 100 records. Okay, I am printing the data whatever our producer is trying to send, and here you can see here I am using producer.send. Okay, here I am passing the topic name and the data what we want to send. So this is the send method. Earlier in fire and forget method, we were not even bothering whether the message is sent successfully or not, right? But this time we are waiting for the response. Okay, so producer.send method will return a future object, and on that future object we are waiting for 10 seconds. Okay, after 10 seconds we will understand that timeout happened due to some reason. The message was not able to be written in our Kafka cluster. Our client producer will be notified, and then it will try the next message send. Okay, so every time whenever one message is sent, it will wait for response. Okay, what response you can expect? Like you will understand in which topic the message was published, what is the partition number, what is the offset, okay, where the message is published. All this kind of metadata information we will be getting, and once the message is done, then only it will try to send the next message, okay. And in the middle, suppose some error happened and one message is not able to be written in Kafka cluster, it will wait for 10 seconds, okay. It will expect the response, this metadata, within 10 seconds of sending the message. If after 10 seconds also if it is not getting the metadata or response, then it will understand that okay, something happened. So what it will do, it will basically go to the except block, because it will raise one exception, okay. Like that it will work. Simple, right? So again I will show you the failure scenario using same technique. First I will start my Kafka blocker, okay. So let it start, and here I will start my consumer also, but this time I don't want from beginning, I just want to get the latest messages, so that is fine. So here I started my consumer, and here what I will do, I will start my Kafka producer, okay. So here you can see that if I just stop in one particular place, here you can see the number what is published, then this is the topic, then this is basically indicating the partition, because we are having only one partition, so this partition 0, and this is the offset number it is sending, okay. Currently we send up to 3940, okay. And here you can see in consumer side also the messages are keep on coming, okay, right. Now what I will do, I will stop my Kafka broker, and intentionally I will try to fail this scenario, okay. And here you can see that the consumer is stopped, but here in the producer side if I go, here you will see if I go completely lower part, here number 64, that particular message it tried to publish, okay, but actually broker is down, so send method will not able to publish the message, right. So here you can see it is throwing an error, Kafka timeout error, timeout after waiting for 10 seconds, okay. That is this particular number 64, our producer was not able to send properly in our Kafka cluster. Our client is getting a notification, okay, and you can store this in an error log. You can monitor that why this particular message writing operation was failed. Is there some issue with our Kafka cluster or not? All these things you will be getting an idea, okay. But every time the exception will appear after 10 seconds only. Like see here, this number 70 tried to publish, okay, but actually the broker is down, so 10 seconds it will wait. Okay, because here we have given in the code the timeout as 10 seconds. After 10 seconds also, if it is not getting any response, it is sending a timeout that see there is something wrong with the cluster, okay. And that's the synchronous process. That is one particular message I am publishing. Until and unless I am getting the response metadata that okay, this is done, I am not moving ahead with the next message, okay. So obviously you can understand this is kind of making the whole process little bit slow also, because most of the time we actually don't require in which partition the message is written or what is the offset number, but at least you will be getting aware in this kind of scenario if you're using send method synchronously that okay, something went wrong, okay. That's the send method, but obviously you can understand this is a very slow operation, okay. So I will just pause this particular process, because anyway we know that this is the reason for failure. Now I will stop my consumer also, and then what I will do, I will go to PowerPoint, and here I will discuss next technique, that is asynchronous send, okay. So we have seen in fire and forget method what is the disadvantage. The client is not even getting any information that whether really the message is written or not, okay. So in any case, if the message writing operation is failed, then also client will not get any notification, okay, and that is kind of drawback. Whereas in synchronous process, we seen the disadvantage is it is a very time consuming process, okay, because every time it is waiting for 10 seconds and then it is going to next message, okay. So here it is a very slow operation. So we need something middle, neither fire and forget where we are not even bothering that whether message is successfully written or not, nor like synchronous send where it is taking huge time just to send a notification. We need some middle approach, right? And that's what the asynchronous send is, okay. So suppose the network round trip time between our application and the Kafka cluster is 10 milliseconds. Okay, that is we are sending a message and then it is written in Kafka cluster. Kafka cluster is sending back the metadata. This whole operation, if everything is proper, then it is taking 10 milliseconds. Suppose, okay. Now, if we wait for a reply after sending each message, like what we are doing for synchronous method, then if I want to send 100 message, then 100 multiplied by 10, I have to wait for 1 second. Whether error occurred or not, then also I need to wait at least 1 second for sending 100 messages. Obviously, right? Because whenever we are using synchronous send, then one complete round trip it is making, because the client is waiting for response, then it is going to next message. So to send 100 message, we need to wait around 1 second. Okay. On the other hand, if we just send all our messages and we don't wait for any reply, like what we did in find and forget method, then sending 100 messages will barely take any time at all, because we are just sending the messages. We are not bothering what is happening in the backend, right? So in find and forget method, sending 100 message will be very quick, right? And in most of the case, we really don't need a reply from Kafka. Whereas Kafka sends us the topic name, the partition, the offset of the record after it is written successfully, which is usually not required by the sending app or the client app or the producer app. Okay. And on the other hand, we do need to know when we fail to send a message completely, so that we can throw an exception or log the message, or perhaps write a message in an error file where the data engineer team can come and inspect why the message writing operation failed, whether there are some problem with the message or whether there are some problem with cluster, right? So we need some middle approach in between fire and forget and the synchronous send. And that's where comes our asynchronous method, where we use the power of callback. What is callback? I am going to discuss with demo. It will be much more clear. So in order to send message asynchronously and still handle the error scenario, the producer support adding a callback when sending a record. Okay. So it will be very much fast, and if some error happens, then it will call a function, and that function will notify us that see some error happened, or if the message operation writing is successful, then another function will be called which will give us the information or metadata that see the message is written successfully, this is the partition, this is the topic, this is the offset. Okay, but it will not actually wait for the response. It is not like one message is sent and then it is waiting to get back the reply, then it is going to send the next message. It is going to send message very quickly, and once suppose the writing operation is successful, then automatically the success handler or the failure handler, depending on scenario, will be called. Okay, so let's see that particular case. So what I will do here, I will just comment out my synchronous technique, and here this is my asynchronous send. Okay, so what I will do, I will just uncomment this particular place and let me explain the code first. So here up to this particular part, it is as it is, whatever I discussed in fire and forget method or synchronous send. Okay, so here comes one particular function. What is this function? I will discuss later. First, focus on this particular fault. Okay, for E in range 1000, we are generating the data from 0 to 999. And here what we are doing, we are calling the send method to send the data. And then here we are adding a callback. Okay, what the callback will do, this callback is taking one function as argument. Okay, on send success. And this is a function. If you see here, this is the function what we have defined on send success. Okay, and then here in the second argument, we are passing the message or the data which was written successfully. Okay, so what this add callback will do, so we will rapidly send message, will not at all wait for response. In the back end, what will happen, if suppose we send a message and that message writing operation is successful, if it happens successfully, then automatically the backend process will call this on send success function. Okay, that's what the add callback is. Callback means it will call if the producer able to write the message successfully. That's all. Okay, so this callback is calling the success handler. This is called success handler because this particular function will be called if the message is written successfully. And if the message is written successfully, what we want? We want to return in which topic it is written, what is the partition, what is the offset, etc., etc. And those all are stored in record metadata, what we have seen in our synchronous send also, that is the topic name, partition name, message offset, etc., etc. For which message it was written, here we are printing. Okay, and then if in the back end suppose we already sent a message and that message writing operation failed for some reason, then automatically it will call on send error. Okay, so this add error back will automatically call on send error function, and this on send error function is, it will basically throw the exception, this message writing was not successful due to this exception, this kind of stuff it will be printing. Okay, so this is kind of asynchronous technique. Here we are sending the message. We are not waiting for the response immediately. We can send the next message, then we can send the next message like that. And in the backend, if any of our message writing operation is successful, automatically the backend process will call success handler or the failure handler. Okay. So that's what we are doing here. So let me show you that. So what I will do here, I will go to terminal, and here I will go to my second terminal. Here I will start my Kafka broker. Okay. And here in the console, again I will start my Kafka consumer also to show you the demo. Okay. Right. And then let me start the process of asynchronous send. Okay. So it will be happening very quickly. Here you can see already 999 messages written. Okay. It is ultra fast. Okay. So if you see here how the messages are getting written, if I just scroll a little bit below, here you can see send message 0, then send message 1. So earlier in synchronous technique, whenever we are sending message, suppose we send number 0, this particular value is sent, immediately we are expecting the response that is in this topic, in this partition, this is the offset number where the message is written. But see here, that is not happening. Once this message 0 is sent, it is sending the message 1. It is then sending the message 2. And like that, it is keep on doing. And here you can see, if I keep on scrolling below, here you can see that it has already sent 123 messages. Okay. And by that time, our first message, what we sent, that is number 0, that message writing operation was successful in the backend. So automatically the success handler is called and it is returning successfully produced this number 0 message to the topic this in the partition 0 and offset 130. Okay. And then it sent another message 124. Like that, messages are also keep on sending, and automatically parallelly in the backend, as soon as any message writing operation is successful, automatically our success handler will be called. Okay. Like here message 1 is writing successful, message 2 written successfully. Okay. And here it sent message 131 by the time. Okay. Like that it is doing. So here you can see messages are keep on sending rapidly, and eventually in the backend it is writing the message. If it is successful, it is sending the response also. So if I go a little bit below, here you can see for all these messages, the writing operation is successful because there is no error. Okay. Right. Perfect. Now let's see one error scenario. How our this on send error will be called. Let's see that, because here we have seen only the success scenario. Now intentionally we will try to fail our code. Okay. By stopping the blocker. Okay. So here you can see what I am doing. The code is same. Just the difference is in between each successful send, here we are keeping a sleep. Okay. Why I am keeping a sleep? Because if I don't keep a sleep, then very quickly the message writing operation will be complete. But I am keeping a sleep so that when the code is running in the middle, I can switch to the terminal where blocker is running and I can stop that. Okay. To show you the demo where intentionally we will try to fail our code. Okay. Right. So here you can see that successful message writing is going on. And similarly in the consumer side, it is consuming. Okay. Right. And now what I will do, I will go to terminal, and in the second terminal where our broker is running, I will stop that. Okay. Here I have terminated the process. If I go to run section, if I go a little bit below, here you can see it is still sending the messages. Message 45, 46, 47, 48, 52, 53, 54, 56. But here in consumer, these are not coming because we are having on a single node Kafka cluster, single broker Kafka cluster, and our cluster is actually down. Okay. So how the client will be aware of that? Because here we are sending the message. Okay. If we just do fire and forget, then obviously client will not get any notification. If we are doing synchronous send, then it is a very slow operation. But in this case, it is not stopping sending the messages. It is keep on sending the messages. Okay. And in the back end, eventually when the writing operation failed, automatically that on send failure, whatever we have written here, this particular method on send error, this particular function it is calling due to error back, and here you can see it is returning to the client that failed to write this particular message. This is the error, Kafka timeout. Okay, batch operation writing failed, expired 30 seconds have passed. Okay, like that message is showing. That means here client is getting a notification that something is going wrong in our cluster. Okay, even it is sending the next messages also up to 99. Okay, whatever messages we are basically publishing here, 100 messages from 0 to 99, it send all the messages, and then if it is failing, it is sending us the response also. If it is passing, then also it is sending us the response that see, this is the topic, this is the partition where it was written. Okay, so in this way, we are sending messages very fast. We are not at all waiting for the response. Okay, so with respect to synchronous process, it is faster, right? And like in fire and forget method, we were not getting any notification if something goes wrong. That disadvantage is also overcome, because here, although we are sending messages rapidly, but asynchronously, the code is calling the failure handler if something fails. Okay, so in most of the time in industries, this particular technique is followed. I hope you understood this. This is all for this video. I will post all these codes in the description box or in the comment section so that you can practice this and get more better feeling. Okay, right? If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.